It has been a long road since the beginning of CSC 111. If you think back to the very first day of 111 where you stared and gawked at what a printf statement was and compare it to now, having seen things like classes and templates and the ability to throw functions around like data, I think that the contrast is more than just night and day. It's like day on Earth and night on some other planet. And I think there's no better way to cap it off to show that we have become masters of the universe than to write some functions that create functions. I would like to show that I am in complete control of everything. Every aspect of the fabric of time and space in C++ is under my control. And so I'm going to use this example to do that. First off, I have this function called countIf. It takes a vector of ints, although we could, of course, define a template. If we want a vector of something else, we are in complete control. It takes a vector of ints. It takes a condition function. We've seen a few of these over the past few videos. It creates a variable called count. I'm going to claim this is a callback, that I've used a C-style initialization there, not an accidental omission. And then all it does is it computes how many elements of the vector the condition returns true on. So just the number of elements for which the condition is true. So it counts the number of counts, I guess, if the condition returns true on an element. Then I have my function main. So I've got this vector here, and I've created a bunch of condition functions. This time, unlike in previous videos, I have created my condition functions using lambda expressions. We know by now lambda expressions are immensely powerful, and this is only touching on the vast power available to me with lambda expressions. But even that isn't really the point of the video. We're going to see some more of that power in a minute. First, I'm going to print out, I'm just going to verify that my countIf function works correctly. We'll try running this. All right, so let's take a look. How many elements are at least 6? There are 4 of them. So this one is at least equal to 6. At least here means including 6. Okay, so there's 1, 2, 3, 4. That sounds good. How many elements are at most 10? So less than or equal to 10. Okay, well, negative 10 is less than 10. Negative 6, that's 1, 2, 3, 4, 5, 6. Okay, that looks good. How many elements are, we get down here, we're going to print out how many elements are even. How many elements are positive? Okay, let's check that. So how many are even? 1, 2, 3, I think there's just 3. How many are positive? Okay, 1, 2, 3, 4, 5. Okay, so it looks like my countIf function is working correctly. It takes the vector, it takes a condition, it counts the number of elements for which the condition holds. Okay, but what's the actual exercise? Task number 1, I want to create a brand new function called between 6 and 10. And I want this function to return true if both of my function at least 6, the condition function to ask if the element is at least 6, and at most 10 return true. Okay, so I'll do that. I will use a lambda expression for that. Between 6 and 10. It's going to be a lambda expression. It's going to need to borrow my functions at least 6 and at most 10, so I capture them by value. It takes an element, we'll call it x, and then it just returns whether both of those two functions return true. So I'm going to write that with logical AND. So I call at least 6 of x, and then I just say I want to return true if at least 6 returns true and if at most 10 returns true. Okay, so I've made a brand new function that returns true if both of these two functions return true. We'll just uncomment that and run that, and then see what the next task is. Here we go. Okay, so we'll verify that. How many elements are between 6 and 10? That means that they are at least equal to 6, including 6, and at most equal to 10, including 10. Okay, so I count not this one, not this one, not this one. Here's one here. Oh, wait, no, sorry. 5 is less than 6. 8 is greater than 6 and less than 10. 9 is greater than 6 and less than 10. There are 2 of them. So I think my lambda expression worked. You're always welcome to look at the posted code and try it out yourself. Okay, well, that's great. I did task number 1 just fine. Here's task number 2. Create a function called even and positive, which returns true if both is even and is. Didn't I just do this? Am I going to have to do the same thing again? Wait a minute, don't we not like duplication in a course like this? Don't we want to avoid redundancy? If I need to keep making up these new functions that return true if both things are true, don't I want to automate that? I don't want to have to keep writing this out by hand. But I guess I can automate it, can't I? I could make a function that does this for me. I could make a function that takes 2 condition functions and makes me a condition that, I guess, refers to both of those things returning true. Why don't we try doing that? I'm going to call my function both. What's it going to return? I think it's going to return a condition function. Well, here's what a condition function looks like. So I'm going to write a function that returns a condition function, and it takes as its argument two condition functions. We'll call them C1 and C2. And the function I create and return will return true on an element if both C1 and C2 return true. So I'll call it result. It's going to capture C1 by value and C2 by value. One reason why you want to capture by value here, I mentioned this in a previous video, is if you capture by reference, you're going to end up with a scoping problem because you're going to return the function and the references may not be current. Okay, so I take an element x and I want the resulting condition to return true if both C1 of x and C2 of x are true. So I make up a function and then I return it. Here I have a function called both that creates and returns a function. All right, great. Now if I need conditions that are just the combination of two other conditions, I can call my both function. So this between 6 and 10 I wrote earlier is both at least 6 and at most 10. And whether or not you liked when I wrote the both function looking at this and thinking this is a monstrosity, what the hell is this supposed to mean? Whether or not you like that, you know by now that C++ is full of a lot of ugly code wrapped around behind things, so encapsulated inside of classes or inside of library functions. It's not about whether both looks ugly on the inside. Unfortunately, this is a very superficial language. It's all about outer beauty. And notice when I call it, this just looks beautiful. The function between 6 and 10 is the function consisting of the case where it's both at least 6 and at most 10. This is actually more readable than what I had before. Okay, but does it work? We'll try it out. And here, I think it doesn't work. I think the error makes that clear. I forgot a semicolon. As I mentioned at the very beginning with lambda expressions, because it's an assignment, you need a semicolon, even though the curly bracket makes it seem otherwise. And even I, as you can see, occasionally forget that. I was so excited about my example that I forgot a semicolon. There it is. Both both at least 6 and at most 10, between 6 and 10, there are two elements, just like before. And now if I would like to test whether something is both even and positive, by making this function down here, that is also pretty easy. Even and positive, well, I guess I have to say auto even and positive. This condition function will be the case where it is both even and, is positive. There we go, and we'll just try that out. Didn't forget any semicolons this time. Okay, elements that are both even and positive. There is supposed to be only one of them. Okay, well, that's not positive, that's not positive, that's not even, that's not even. This is even and positive. There's one element that's even and positive. Nope, nope, and nope. So indeed, there is one. My both function worked. I took two condition functions and I made a brand new one. I synthesized a brand new one in my both function. We're not done yet. Okay, so now I want to create functions called not even and not positive, which return true only if the number is not even, well, I think this is self-explanatory, not even or not positive. And I think, okay, this is again one of these tricks where I'm supposed to take one condition function and make another. And you want me to do it twice? I'm not going to do that manually. I'm going to write a function. So I want to go from having this condition function, is even, to having the opposite condition, not even. We saw in a previous video that we can do this. I could write a function that returns the opposite condition. So it's going to return a condition function, so I'm going to call it opposite. And it takes a condition function, we'll just call it C. And I'll just adjust my spacing for taste. There we go. I'm going to create myself a new lambda expression that captures by value my condition function C, and it takes a value x. And this condition function will return true if C returns false and vice versa. So if C of x is equal to true, then I return false. If otherwise, then I guess C of x return false, I return true. So I've just made a condition function that is the opposite of whatever function you gave me, and I return it. I now have this function opposite that is a factory for getting the opposite of some condition function. I no longer have to write that myself. I'm going to take a quick check to make sure I actually have the semicolons, and I do. And so we'll go down here and it says create functions called not even and not positive, which are the opposite of those functions, those condition functions I used above, is even and is positive. So the not even, not positive. And they're both going to be, you can use auto in place of their type. And I will say, okay, that equals the opposite of is even. I'm continuing to use C-style initializations for these functions because I did use them up here. And I mentioned earlier that the C-style initialization just seems to fit lambda expressions a bit better than uniform initialization. And then not positive equals the opposite of the is positive function. I should also say that whether or not C-style initialization is a valid thing to use, which it is, it's the last week of the semester. We can let our hair down a little bit here. So I use the is even function. I create the opposite to that, and I've got my function not even. Let's see what happens if I use those. So I should therefore be counting the number of elements that are not even and the number of elements that are not positive. And it compiles. There it is. How many elements are not even? Apparently there are 5 of them. Okay, so that is even, that is even. Here's one that isn't. There's 2, there's 3, there's 4, there's 5. There are 5 elements that are not even. How many elements are not positive? 3. Okay, well, there's 1, and there's 1. It looks correct. I've been able to use my opposite function to manufacture for me the condition that I was looking for. But we're not done yet. Now I want to count the number of elements of V that are neither even nor positive. That is to say, the number that are both not even and not positive. I'm going to actually fix that typo. I'm going to say this is the number of elements that are both not even and not positive. And there we see that word both and that word not. I've already figured out how to go to the opposite of a condition. I want the opposite of is even if I want not even. And I've also seen how to combine conditions using the both function. And in fact, in here, although I could make new variables like I did above, I'm not going to do that. I am deliberately going to just use my functions. It turns out all along, I didn't even need these variables. If I want to use the condition of not even, I could just use the return value of opposite. So here I want to count the number of elements that are both not even and not positive. And so I'll just combine my conditions directly. The condition I pass into count if will be the condition of being both the opposite of is even, so not even, and the opposite of is positive. There we go. So there's my call to both. I am manufacturing a custom condition just for this print statement. I'm never even giving it a name. It's a function that is truly nameless, and it works with 2 other nameless functions returned by opposite. And so we'll try that. All right, things that are neither even nor positive. Okay, so this is even but not positive. This is even but not positive. So I want things that are neither even nor positive. Okay, this is positive, it doesn't count. This is positive, doesn't count. This is positive, this is positive, this is positive. Here is the one element that is not even and not positive. And we were able to use our opposite and our both function to create a condition on the fly, to create a function for us. And so now across 2 programming languages, you now know C and C++. You know them both. And so what better way to end this journey than to literally write code that can write code for you?